Okay, so it should be there. And the reason I'm doing that is I'm going to talk a little bit about doing the design and the principles of it first, and then we'll kind of adapt the other thing. This is Lucidchart. I don't know if you can see at the top. I'm going to zoom up so you can see the address a little better. This is just Lucidchart. You just want lucidchart.com. Let's go there instead of the login for right now. Oh, I didn't want to do that. This is, so I just want lucidchart.com. I don't know why it went to that. Let me zoom down because the web page is zoomed. So you can sign up for free. Generally, you don't want to do that, though. What you want to do is go down, way down to the bottom, and where it says education. And if you click on that, if you have an EDU email address, you can sign up for free. Lucidchart is basically a program where you can create all sorts of charts, including database relation charts. You can also create UML charts for programming, or flow charts, or charts to redesign your bedroom. You know, whatever you want. If you do the free version, the sign up for free without the EDU, it lets you draw like one drawing, and then you're stuck. It won't let you do anything more. So again, what I would do is, if you go so I'm going to go back. And if you go to just lucidchart.com and you go down, don't do the free, but go way down to the education, solutions and educations. And then you'll need to know your EDU email address. Is yours the same as mine, first name, last name, at seattlecentral.edu? I think you guys all have that. You may not use it. But if you have the EDU one, you can sign up for free. If you don't want to do that, so we need a charting program. There are other charting programs that you can have. I was looking, David did not install Visio this time. So Visio isn't available on the underlying machine. You could, worst case scenario, draw these by hand and take a phone picture of them when you turn them in, but I'd rather you did it electronically. So I'm going to log in. And I did an EDU one, right? This is just going to be an overview of a little bit of what the charting looks like, and then we'll take what we did in terms of coming up with fields, and we'll start to chart that and then talk about that. So but you can, as I said, with an EDU, you can get a free. Now you'll have to register when you do that. Did that not work? Oh, log in with password. I always do that. I click next. That's not what they want you to do. They want you to log in with password. Password is why did that fail? I wrote it down. Let me check it. Well, this will be fun if I don't get in. I'm going to try one other thing. It's possible that I did. Nope, that's not right. I'm sure of this part. Let me check real quickly again. Positive that's the top speed. I figured out what it is. I had a long email. What?
Locked.
Am I locked out?
Yeah, you said to me locking that thing to try.
Oh, to me, try later. Shoot. That's why it's not working now. Let's try it. Come from a different place. Probably has the same IP though, right? So I don't want to sign up in free. I want to log in. Don't you hate passwords? Hi. That was correct. It's still locked out? Yes, yes. All right, what do I do differently here? So I didn't see Visio anywhere on here. So this will be really bad, but let's try Paint or something. What would be a good diagram? Something you can draw in.
Diagram?
Yeah.
Do like a PowerPoint or something.
Yeah, except there's no PowerPoint on here. But I could do. We could use Google Doc.
Google Sheets.
Yeah, Google Sheets would probably work. So you get to see me. Lucidcharts anyway is good. I left out a character in my password, which I saw in my office there. So let's go. I'm going to go to the drive. I wonder, do I have any database? Database summary, database security. Let's see what this has. Since I can't draw it, maybe I have some drawings. This may not be as much fun, but it'll go over the basic ideas. And then we'll do the other. We will do the other when I can get back in. Okay, so this is really the principles of relational design. and the kind of how the design is put together, then what we're going to do is we'll take the data that we generated, brainstormed, and we'll start working in groups, probably early, maybe as early as Wednesday, and start to actually create a design. And then we'll modify those designs. We'll go through them and critique them and fix them. So this is not the way I would prefer to do this, but when we do this, we're going to draw entities. So entities are, there's no pins in here. I'm going to show you in a bit, but an entity basically is a square box like this, and it represents what will probably be a table. So this would be like customer. And then in here, you usually have your key, and then you list all of the attributes. And the attributes are like what we brainstorm, the fields, right, to go with it. So these are the things that a database deals with. The entities, when you're designing it, you think about what are the things that the database is going to deal with. So in a point of sale, a database, we did this, right? There'll be customer, sale, inventory, employee, etc. And entities often become tables. And I say often because sometimes when you do the design stage, when you start thinking about them, you have to break them up, make them more complex. Entities are the same thing as tables, except they're in the logical design phase, not in the physical stage. Once you've created them, they're tables. That makes sense? Entities is design, tables are the actual database. So an attribute is something that describes an entity. And again, like with customer, you might have things like customer number, last name, first name, email, phone number, etc. And attributes are general descriptions, not specific to an individual customer. So you would not have George as attribute or Wilson. It's the headings of the table. Does that make sense? Like the spreadsheet, that'd be the heading columns, not the data underneath it. Attributes often become the column headings. So this is an important thing. I haven't done this PowerPoint maybe ever, so we'll see how it goes. Primary key is an attribute that uniquely describes an entity. Now, it doesn't actually have to have much descriptive power. A customer number, right? You give them a number. Student ID, right? It's a number that uniquely assigned to one student. Every entity should have a primary key. It's not an absolute rule, but it's best design. Every entity should have a primary key. And then these are talking about types of primary keys. This isn't all that important, but there are natural keys. That's basically where you have attributes that describe the entity. Like an email address could be used. A lot of places use email address for a key. Theoretically, each customer only has one email. Or not that they have one email, but they're the only one with that email. Does that make sense? Or a phone number. Pizza places use a phone number, typically. So a natural key, the trouble with natural keys are, can you think of a couple?
They can change.
They can change. That's one of the problems. They're volatile. Email addresses can change. Phone numbers can change. They tend to be too tied to the business information. So if the business needs change, the key could become obsolete. And then the biggest problem with a natural key is it's really hard to guarantee that they're actually unique. Because one of the things about a primary key is it can never be repeated in a table. It has to be unique for every row in the table. It can never repeat. And it's really hard to find natural keys that you can guarantee that. Surrogate keys, which is actually what I would use most of the time, are just where you assign an automatic number or something. I'll show you ways where you can just basically just auto number, your records. So customer 1, customer 2, customer 3, just auto number down. Surrogate keys don't have any meaning, so they don't change. They're not tied to the business information, so it's irrelevant if the business information changes. There are some drawbacks to them. Anybody have a guess? There's, it doesn't keep you from entering the same person a dozen times because each one will have a new number. So there's no protection against repetition that way. Also, although this is something that we're not going to be involved with, if you merge two databases that have primary keys that are surrogate keys, it can be really confusing and a difficult process. We're not going to be merging things, but composite keys. That's a single key that is made up of more than one attribute. And one of the examples I use is if you know the class schedule for school, every class has an item number, right? But that item number is used over and over again, and not always for the same class. All right, so the item number is unique in a quarter, but it's not unique across time, across like a whole year or multiple years. So in order to get a unique number, you need to know the item number, you need to know the quarter that is used, and you need to know the year that is used. So if you had those three fields together, you could have a unique combination. And that's what a composite key could be, is you could make a key out of those three fields together. Composite keys are kind of awkward, and I usually avoid them, except when we talk about linking tables, which I'll do. I often put composite keys in those. Does that make sense for types of keys? The other thing that this is probably a little premature on is that keys are the way relational databases keep track of what data relates to other data. Every record has a primary key, and it's repeated in another table as a foreign key. And that's what ties those two tables together. So every customer has a number. When you do a purchase, you have the customer number in the purchase or the sale, right? And it's the customer number that ties the customer information to the sale. That's the only piece of information you need in the sale to tie it to the customer. You don't have to repeat their names. You don't have to repeat their emails. You don't have to repeat any of that information. There's a couple of other keys. Again, these don't matter. Candidate key just means something could be a key, but you didn't make it a key, so I'm not sure if it's really a key. It's just something that you could be reasonably considered as a potential key. And an alternate key is any field that you designate as unique. For instance, you could have a numbered primary key, but you could put a unique constraint on emails. All right, so emails would have to be unique. It would force that, and they're considered an alternate key. They actually put a little key beside it in the diagram sometimes. Even though they're not really a key, they're unique, so they could be used as a key if you need it. There's actually a lot there that doesn't matter to us too much, that it's fairly subtle. I'm not sure. So here's an entity. And this is a picture not from Lucidchart, but from Visio, which is Microsoft's tool for making charts. This is a department. This is the department key. You don't have to name a key. A lot of people prefer ID. These are attributes, the name, the office number, the department phone. You probably have more of them, right? The ones that are bold, can't tell which is bold and which aren't there. I think they're all bold. They're the ones that are required. So it says all these attributes are required. That's what an entity looks like in a design. Anyway, that makes sense? It's just a box. Keys are usually indicated, and you list out the columns. You can, there are variations on these where you also list out the data types here, but that's really when you're getting to close to the production stage. You don't really need to know the data types logically. Okay, so that's a diagram. So then we talked about primary keys. Foreign keys are the primary key repeated in another table, like the customer key repeated in the sale table. It ties it together. Primary keys are repeated in other tables to tie them together, and when they're in another table, not their own table, they're called foreign keys. And foreign keys, unlike primary key, foreign keys can repeat as often as necessary. So if one customer buys frequently, that's not a problem. Does that make sense? There are three. This is where I was going to go, but this Google Slides is going there a little faster than I probably would have. There are three kinds of relationships between entities. We only look at one entity, right? But we're going to look at. There are three kinds: one-to-many, one-to-one, and many-to-many. Okay. And we will spend a little time on this when I can get into Lucidcharts. Did anybody have any idea how long they lock you out?
Log into one of ours.
Yeah, it's okay. We'll just go with this for today, and then Wednesday I'll log in and we'll get it going.
I think usually about 10 minutes.
Is it 10 minutes?
Yes.
Well, we'll try. I'll go through this and then I'll try to log in and we can look at it. This is what most relations are: one-to-many. One customer can have be involved in many sales. Does that make sense? One department can have many employees. Right, one-to-many. One album can have many songs. You were doing that. One-to-one is very much less common. In fact, you might never encounter one. One means that for every record in this table or entity, there is exactly one related record in the other one. There's a couple of instances. Well, I probably am just anticipating what's ahead of this.
Department chair.
What?
Like department chair.
You could do like department chair and department if each department has one chair. You could also, although if there's only one, you might just put it in the department thing. One of the things that they sometimes do, and I think this is in here, is for security reasons, although this is not your best approach, they might have a public employee table and then a private employee table. Public has stuff that can be shared, and the private one has the tax information and addresses and things like that shouldn't be shared. And they're a one-to-one relationship because for every employee in the public table, there's exactly one employee in the private table. Does that make sense? One-to-one. It's as I said, this is a legal relationship, but it's really rare, and I'm not sure you will actually encounter that much. Many-to-many is really common also, but databases can't figure them out. So many-to-many would be like one of the examples I use a lot is author book, or album artist. Each album could have many artists. Each artist can have many albums. It creates an ambiguity that it can't resolve. And it has to be resolved by creating a linking entity, and we'll talk about that. That converts the many-to-many into two one-to-many relationships. There's a lot of things like that, where one author can have many books, one book can have many authors. There's a lot of relationships like that have to be resolved. Okay, one department can have many employees. So here's a diagram of that. And we will, when I get into Lucidchart, I'll show you how to do this. This is the one side, this is the many. This is what you call a crow's foot diagram, the relationship. At this point, I wouldn't worry too much about the zeros. One of the things I like about Lucidchart is that it pretty well ignores these things. It just does the one side and the many side. The crow's foot is the three-toed many side, and then this is the one side. So one to many. One department can have many employees. And I don't know that you can see it here, but there's a department key as a foreign key. The department key is repeated down here, and that ties the employee to the department. That's all that's needed is to repeat the key to figure out which employees are in the department. Does that make sense? If it doesn't, you can always stop me. Okay, I'm going to assume it makes sense. If it doesn't make sense tomorrow, that's okay. Okay. This is an example when you look at the data. So notice these are the department keys, 1, 2, 3, 4. And it gives, the department name, department office number, department phone. Down here, these are employee keys. And again, they're just numbers. And then down here is the department key. So these two, Salmon Taylor and Mary, I guess it's Taylor Salmon, and Mary Nelson are part of the information technology department, because it's two. And Jennifer Lewis is part of human resources, and Mike Green is part of sales. We don't have anybody down there from customer relations at this point. Does that make sense? You just can tell them by matching the keys where they go to. Now, one of the things about this is when you're looking at this table without this one, you may have no idea what that department is. It's not necessarily humanly readable, and there's an instinct you're going to want to put the department name there. But you don't. You don't want to repeat anything that you don't have to. Only the key should be repeated. Relational databases are designed for the computer. The front end, which is not what this class is about, the web pages, the forms, and all of that, those are designed to bring it all back together for people so that they can read it in ways that make perfect sense to them. Okay, so one-to-one relations occur when there's exactly one related instance in another entity. Typically, they share the same primary key. Like if we split employees, there would be an employee key in one and an employee key in another. So if we create a login entity where each employee has their login information, there would be exactly one login for each employee, and that I did this. One-to-one, there's no crow's foot there, it's just one. Right? And they both have the employee key. So this is the employee key, and this is, actually this would probably, you could argue this could be a foreign key too, but does that make sense? It's just one-to-one. This is so rare that you're really unlikely to use it. Questions on that? I see puzzled looks, but we'll go on. This won't be our only take of this. So here there's Louis Jennifer. Her username is Jen. This is her password, which goes on forever. Okay. This is her hashed password. It's fun to hash. That's not really relevant here, but the hashes are supposed to be one way only. They're unlike encryption. Theoretically, you can never resolve this into their actual password. So what you have to do when you're doing that is you have to match the hashes. You have to rehash it and match it and see if it matches. All right. So many-to-many relationships are really common. If an employee could hold many or in many positions, if we create a position entity, one employee can have many positions. Each position can have many employees. So that's a many-to-many. Another one that's real common is one class can have many students, and each student can have many classes. Does that make sense? Many-to-many are really common. So this is diagramming a many-to-many. This is legal in a diagram, but again, no relational database can handle that.
For a drawing.
What?
Looking for a flash drawing.
Oh, did you forget? Is that yours, Zach? Okay. Good. I'm glad it was still there.
Sorry.
No, that's okay. I'm glad it was still there. So this is a logical diagram, but it won't work in a database. Basically, it creates kind of a loop, and it can't figure out how to get out of it. So you have to create a linking table, basically. So this is like employee, and this is position, and this is employee position. I do use composite keys here a lot. You don't have to. So the idea is that an employee, as long as the pair is unique, it's good. So an employee can hold any number of positions, right? Same employee key, but a different position key. Or the position key can change and the employee key can change. Either one of these can repeat as many times. It's just that the pair has to be unique. Does that make sense? I'm thinking it doesn't. But let's see if I have data. So we have, let's look at employee. This is position 2. Do I have employee? So employee 1, Lewis Jennifer, holds a position 1, which is human resources specialist. She also holds position 5, which is payroll manager. Right. So the employee key is 1,000. It repeats twice, but these numbers change. So she holds position 1 and 5. 2 people are in position 2. Position 2 is IT Tech 1. So person 1001 is an IT Tech 2, and 1002 is an IT Tech 2. And then person 1003 holds position 4, which is a sales manager. Does that make sense? I mean, that's how you resolve a many-to-many, is making a little table like this. Again, when you look at a table like this in a database, if you don't have these two things open at the same time, this isn't going to make any sense whatsoever, and that's fine. It doesn't matter. The database can resolve it. When you're writing this for people, there's a thing we'll do later called SQL joins. And a join would bring information from all 3 of these tables together in a way that would make it make sense to people. And then I have some references. All right, let's see if I can get back in. So see if I'm still logged out. If I am, we may just call it good. Yay. You might see that we have some Vince's ERDs in there. I'm not going to, those are not, I think those are shared with me. One of the things you can do with these is you can share them in Canvas so that I just share them with me, and then I can view them in Canvas. Let's see if there's one of these that I want to look at. I guess we could just do one. I'm not sure what this is. I'm going to look at it and then we'll make a blank one. Oh, I know what that is. That's not going to help us. So let's close it. I can remember how to close it. Is it just because I'm not present? Oh, well, let's just open a different one. File, new document. I'm just going to do, is it blank? Basic service, blueprint. Let's just do a blank one. All right. And then over here, I want to do shapes. And when I click, well, I want shapes. I want to bring in some new shapes. That's standard. That's not what I want. I don't want flowchart. Let's do plus shapes. And then we want to do entity relational diagrams. Are they there? iOS data flow.
Relationship.
Yeah, you see it?
It's like
Oh, right there. Good. I don't need the default or the geometric. Let's just do the entity relations. I'm zoomed kind of big, so I'm having trouble. Okay. So there aren't a lot of shapes here. And I would probably use the one here where you can just drag the entity on here. And I'm going to start, I'm just going to real quickly kind of go over the some of what we did, and we'll do a couple of those. I'm not going to do all of them because that's part of what your job will be later. This one just allows you to put the field names. It doesn't have a place for the key. This one has a place for the key, so I think it's a better one. This one lets you put in data types. So I'm not sure why that's split like that. This one lets you do data types. Doesn't matter. I'm going to just use the second one. Let's do like the easy one first. Let's do customer. So you just type that there. PK, we could do, what do you want to call the primary key? Customer number, customer key, customer ID. What do you want? ID. Couple of things about these. So I'm just going to delete those. Whoa. Control Z. It's just trying to delete the extra keys there. So when we do a field, we can do like, let's say last name. Since let's be a little first name. And then when you're down here, if you do below, it'll add a thing. Say email. Phone. What else would we might want? Possibly, yeah. So do address. You want city, state, all of that. Don't need address. It's up to you. One of the things you have to do is decide how intrusive you want to be about your customers. Mainly phone and email contact would probably be good enough, unless you intend to ship things, which is a different issue. So I can always delete the last one if we don't want the address. I think I have to make sure that I select just
You can change the fields at the top left. Go from 6 to 5.
5. That's probably faster. Yes, good. Good hint. All right, so there's an entity. Okay, let's just do one little piece. And I'll just show, I'm going to bring this out. Let's make like a request. All right, so probably there would be like a request ID. And if you wanted to do the, you'd have like the customer ID. That would be the foreign key. So let's just type FK in there. What else would we want in there? We don't have to do all of it. I just want to show how this works. So we'd want to know what item. I don't know how you want to do it. Notice one thing I want to mention. Notice how I'm running the words together. So spaces are illegal in a name. If you don't like to run them together like that, it is possible to, the other legal character is an underscore, right? It's entirely up to you which you want to do. There's other naming conventions too. Sometimes I put like customer last name, customer first name, customer email, customer phone. I mean, I have like the table name in front of every field. That can be really useful later on when you're doing queries because you know exactly what table it came from. On the other hand, it's a pain to always type that. Same with the request. I usually leave foreign keys the same name as the primary key. Now, when I do a relationship here, you just grab one of these dots and you drag down to there, and it gives you the relationship. The trick with this is you have to know which way to drag, right? You're dragging from the primary key to the foreign key. You can change it. If you decided that it's wrong, you can go up here and you can change what the endpoint looks like. Also, if you wanted to get, I say I don't worry about these things like the 0. Technically, this means one customer has many requests. If you put that little circle there, it means one customer has 0 or many requests. It really doesn't make much difference in the actual database, but it's what they call cardinality. It's not something I'm going to spend much time on because the databases don't enforce it. You can put it there in design to show your rules, but the database isn't going to enforce those rules. So I don't bother. Do you see how, so you can just drag these in. And when you're done, you can make there is actually a nice thing up here that'll arrange them, auto layout. And it'll arrange them in a hierarchy, and it makes it a little more readable sometimes. Okay, so I think I'm going to let this be good for today. And what we'll do next time is we'll talk a little bit more about the rules of how we'll take a couple of those tables that we created and we'll decompose them a little bit, talk about normalization, and then I'm going to let you guys get into groups and start working on that, the design. So the design part is a group project. When we actually implement it in the database, I let you do it as an individual project, right? So you can share the group design, because I think it's really good to talk for that. You have multiple people to converse with on that. And then, as I said, individually, you can actually create the database and enter data and test it. And then we'll go back, we'll do another relational design with MySQL, and we'll do that. So I don't think you have quite enough yet, but my brain is shot. I don't know about yours. It's Monday. I had no power yesterday. I'm kind of, and then I didn't get out of the morning class until 5 minutes before this class started. So my brain's gone. I will. So there's a video. It has some dead spots in it. I will post the notepad thing that we did in blogs, and we'll use that next time because I want to make a couple of the tables as we designed them, and then talk about how and why you might break them up into smaller tables.
How do we make account on
You should have one. It's the first letter of your first name and your whole last name. Did you try that? And then if the initial password, if you haven't done it before, is password. How many? That's actually something, it's not important today, but it will be important in about a week, week and a half. You should have your own account.
the first letter, third name?
And then your whole last name. And then capital P at SSW0 or V1. If you don't have it, I should ask you to change, yes. All right, I'm going to, I think it's saved. This auto saves, which is nice. I'm going to kill the video.